Good afternoon. Here we are again to put forward everything you ever wanted to know about computer vision. So, I'll not talk about long ago kind of stories. Let's get to the core part of it that will excite you. The concept of computer vision was first introduced in the 1970s. The original ideas were exciting, but the technology to bring them to life was just not there. Only in recent years did the world witness a significant leap in technology that has put computer vision on priority list of many industries. One of the most powerful and compelling types of AI is computer vision, which you have almost surely experienced in any number of ways without even knowing. It focuses on replicating parts of the complexity of the human vision system and enabling computers to identify and process objects in images and videos in the same way that humans do. Until recently, computer vision only focused on limited work. Thanks to advances in artificial intelligence and limitations in deep learning and neural networks, the field has been able to take great leaps in recent times and has been able to surpass humans in many tasks related to identifying and labeling objects. One of the driving factors behind the growth of computer vision is the amount of data we generate today that is then used to train and make computer vision better. Application of computer vision technology is very adaptable and can be adapted by many industries in very different ways. Some use cases happen behind the scenes, while others are more visible. Most likely, you have already experienced the products enhanced by the innovations. Here's a look at what it is, how it works, and why it's so awesome, and is only going to get better. Computer vision capabilities we have under deep learning toolkit are object detection, face detection, and image classification. Let's begin with object detection. On a certain level, object detection is all about recognizing the objects. So, one way to train a computer how to understand data is to feed it with images and then subject to those various software techniques and algorithms that allows computer to find the pattern of images. Deep Learning Toolkit supports differentiation. You can compare outputs of two different softwares under one platform. Clearly, select TensorFlow and Microsoft Azure. Click on Choose File. View input as image and then click on Submit. You can see the output. The object here is detected as bicycle and this as a person. All these were cars. In parallel, Microsoft Azure traces it as a person, cycle, and cars. This helps us understand and analyze scenes in the image. This then allows us to find and traces the objects. Deep Learning Toolkit is a boon to business industry. It is a time savior. This object detection has all the power to detect various objects in a single image. Forward looking to face detection, this innovation enables security of public places like parking lots, railways, bus stations, and far more. Face detection for security purposes has major advantages. This technology helps to strengthen the security and prevent accidents from various kinds. To recognize a face, it is first important that we locate a face in an image. There are various facial detection softwares. Popularly used softwares were OpenCV, Azure, DLIB, and MTCNN. Select the softwares and then click on Choose File. View the input as file. Now it's time to click on Submit. This is the final output where all the faces were detected. There are many benefits to face recognition systems, such as it is convincing and time saver. It is easy to use in many cases with just a person image. Next, moving to image classification. This is a technique used to predict the class of specific object in the image. The main goal of this technique is to accurately identify the features of the given image as input. Few image classification techniques are IBM Watson, TensorFlow, and Azure. Select all the softwares and click on Choose File. View input as image. Then click on Submit. The final output is in TensorFlow, Egyptian class has confidence rate of around 62% and then Siemens cat with 15%. This confidence value represented are calculated for the single input, which will give the meaning of how much the algorithm is confident in the particular class. Here, in the case of Egyptian class, the confidence rate was around 62%. Comparably with IBM Watson, Animal with the highest confidence rate of 96 and with BG Color with 100% rate, which is accurate. Likewise, in Microsoft Azure, CAT with a confidence rate of around 99% and Outdoor with 97%. This is all about computer vision.